In this slide, we'll be talking about vapor pressure. The air moisture content may also be described by measuring the pressure exerted by the water vapor in the air. Suppose that the air parcel is near sea level pressure. The total pressure inside the parcel is due to the collision of all molecules against each other inside uh, the surface of the parcel. In other words, we can say the total pressure inside the parcel is equal to the sum of the pressure of the individual gases. If the total pressure inside the parcel is 1000 millibar, the gases inside includes nitrogen 78%, oxygen 21%, and suppose that water vapor is only 1%. Then the partial pressure exerted by the nitrogen would be if nitrogen is 78%, then the pressure would be 780 millibar, and the oxygen is 21%, so pressure would be 210 milligram. So the partial pressure of water vapor would be actual vapor pressure. So water will contain only 10 millibar because the water content was 1%. So the partial pressure of the water vapor is called actual vapor pressure. Well, the number of water vapor molecule in any volume of the air is small compared to the total number of air molecule in the volume. The actual vapor pressure is normally a very small fraction of the total air pressure. The more air molecule in a parcel, the greater the total air pressure. When you blow up a balloon, for instance, you increase its pressure by putting in more air. Similarly, an increase in the number of the water vapor molecule will increase the total vapor pressure. How is that? The actual vapor, excuse me, the actual vapor pressure is a fairly good measure of the total amount of the water vapor in the air. So, the high actual vapor pressure indicates large number of water vapor molecules, and the low actual vapor pressure indicates comparatively small numbers of vapor molecules. Actual vapor pressure indicates the air total water vapor content, whereas we call saturation vapor pressure. It describes how much water vapor is necessary to make the air saturated in any given temperature. We all know the saturation temperature, so saturation condition of the air. So let's talk in different way. The saturation vapor pressure is the pressure that the water vapor molecule would exert if the air were saturated with vapor at any given temperature. We can obtain a better picture if we look at over here. So this water molecule, imagine this water molecule vaporizing from a water surface, and if you remember the previous talking that when the air is saturated, the number of molecule escaping from the water surface equal to the number is returning. In a saturation condition, this is the situation. Since the number of fast-moving molecule increases as the temperature increases, the number of water molecule escaping per second increases also. To maintain this equilibrium, this situation causes an increase in number of water vapor molecule in the air above the liquid. Consequently, at higher temperature, it takes more water vapor to saturate the air, and the more molecule exerted greater pressure. Saturation vapor pressure then depends primarily on air temperature. So always have to be remembered that saturation vapor pressure is depends on air temperature. Well, if we look at this graph over here, this liquid ice, this is liquid, this ice, and this line is telling us the saturation vapor pressure, and this horizontal line is temperature, and this vertical line is talking us the water vapor pressure in millibar. So we from this graph we can assume some informations here, that if we can see the 10 degrees centigrade, the saturation vapor pressure is about 12 millibar. Over here this is the 10 degree, so water vapor pressure would be 12 over here. Whereas 30 degree, if you were looking at the 30 degree over here, it would be 42 or 41 millibar. So when both water and ice exist in the same temperature below freezing point, this is important. When the water and ice exist in the same temperature, which is below freezing point, the saturation vapor pressure just above the water is greater than the saturation vapor pressure over the ice. Simplifying this is, as at any temperature below freezing, it takes more vapor molecule to saturate air directly above the water than it does to saturate air directly above the ice. This situation occurs because it is harder for molecule to escape an ice surface than the water surface, because ice surface is solid. So consequently, fewer molecule will escape the ice surface at a given temperature, and requiring a fewer in the vapor phase to maintain the equilibrium. So we know from here that what is the vapor pressure, what is the actual vapor pressure, and what is the saturation vapor pressure. Those information would be very important in coming talking. So please pay attention on this. Thank you.